Hope everyone's doing well. Let's jump into special products in 7.3. Good stuff here. Fairly quick lesson here with one natural place where you may want to take a break. But go ahead, start this warm up. Remember, we have a binomial times a binomial in each of these. So you're going to, what method do we probably want to use? FOIL method, right? First, outside, inside, last. So go ahead and do those. And I want you to look, especially on the first one here, notice what happens. All right, here we go. All right, so you can start the video back up. So x times x squared, outside is negative 2x, inside negative 2x. Notice how we have two of the same thing there that we're combining together to make negative 4x, and then negative 2 times negative 2 is positive 4. So this is a positive there. Remember, it was the same binomial multiplied. So think of another way you could have written that with an exponent. Okay, on this one, hopefully you got y squared plus 7y minus 18. And this one, a little more complicated because you have variables with coefficients, but still same stuff. 4a times 3a is 12a squared. Outside is 24ab. Inside 3ab, combine those together. And then b times 6b is positive 6b squared. Okay, write an absolute value equation that has the given solutions. Ooh, remember this? Absolute deviation. So what would it be? Remember how you find the midpoint of those? What's the midpoint between 9 and 17, or the mean? Think of it that way. Remember this? So remember, you go absolute value of x, and then what's halfway between 9 and 17? Well, they're 8 apart. So if we add 4 to 9 or subtract 4 from 17, we get 13. So remember, we set it up like this. And then equals what? Remember, it's the distance they are from that middle point, which we said was 4. Okay. So then we can set up our two equations. So we have x minus 13 equals 4. Or what's the other one? Whoa, that's not good. Let's get rid of that. 4. What's the other equation? Remember? X minus 13 equals what? Yeah, the opposite, right? Because if x minus 13 is equal to negative 4, when I take the absolute value of it, it's still going to equal 4. So I don't know why that does that. That's so annoying. It's like it freezes or something. Negative 4. Okay, and then you can see that if you solved each of those equations to check your work, if you added 13 to 4, you get 17. If you add 13 to negative 4, you get 9. Okay, awesome. Okay, so your learning target is to be able to, in certain circumstances, recognize that you can multiply without having to go through the whole process of foiling, okay? And you're going to see that in these 3 potential situations. When you have what we call conjugate binomials, notice how it's a plus b, a minus b. We call those conjugate, C-O-N-J-U-G-A-T-E, binomials. First term's the same, second terms are opposites of each other. That'll be one situation. Or when we have a binomial that's all squared, either a plus b or a minus b, okay? And again, this will allow you to not waste precious time out of your day so that you can do more important things, like put pictures of your cat on Snapchat or something like that. Okay, so let's work on this. Write the product of 2 binomials modeled by each rectangular array of algebra tiles. So if we had, this is algebra tiles, right? Remember, x plus 2, x minus 2. Go ahead and multiply this out. Remember, you go this term times this term times this term, then, you do all 4. So go ahead and do that. So positive x times positive x is positive x squared. 2 times x is 2x. X times negative 2 is negative 2x. And 2 times negative 2 is negative 4. Okay. What can we combine together? Where are our like terms here in our algebra tiles? Yeah, right here. Positive 2x, negative 2x. What happens to those? Adios, they disappear. So what are we left with? Just the x squared minus 4. Okay. We call this a difference of two squares. See how it's a difference subtraction of something squared minus something else squared. 2 squared would be 4. Okay, so try this one. Set this one up with your algebra tiles. Okay, so hopefully you set it up like this. 2x minus 1, 2x plus 1, and then multiply. So 2x times 2x, negative 1 times 2x, 2x times positive 1, negative 1 times positive 1. Okay, go ahead and fill it in. So hopefully you have 4x squared, right? That's 2x times 2x. And then negative 1 times positive 2x is negative 2x. Positive 2x times positive 1 is 2x. Negative 1 times negative 1 is negative 1. Negative 1 times positive 1, excuse me, is negative 1. What cancels? Yep, our middle terms. And what are we left with? 4x squared minus 1. So what you're seeing is here we had conjugate binomials. Here we had conjugate binomials. Notice the pattern. Difference of two squares. Difference of two squares. Just the first term squared minus the second term squared. First term squared here was x, right? So that's x squared minus the second term squared. So 2 times 2, 4. All right. So go ahead and write this one out. Notice it's x plus 2 quantity squared. So what's our algebra tile setup going to look like? You're going to have an x and then 2, an x and a positive 2. And I'm going to have you guys just do that one on your own. Okay. But what should you get? Do it right. You're going to get x squared plus 4x plus 4. Okay. And with this one, again, I'm going to have you just do it, but you're going to end up with 4x squared minus 4x plus 4. Okay. And if you have questions about that, we can definitely go through that together. But what I do want you to notice is if you did this correctly, you're going to get a positive 2x and then a positive 2x. So we're getting the same thing twice for our middle term. And here's the same thing. We're going to get a negative 2x and a negative 2x. Same thing twice. And we get negative 4x. Okay. All right. Now let's go ahead and look at this. So these are binomials squared. Okay. Square of a binomial. Okay. A plus b here is squared. Here it's the quantity a minus b. Okay. Same situation. Okay. When I multiply those out, you get what's called a perfect trinomial square. Okay. You get first term squared, double, meaning 2 times, right? The product of the two terms, a and b are the two terms, right? Plus the second term squared, plus b squared. Okay. Here's that kind of written out as algebra tiles. A plus b, a plus b. A times a squared. B times a is ab. A times b is ab. Oh, 2 of those, 2ab, right? And then b times b is b squared. Okay. Up here, here's it written out kind of algebraically. Think about it. You'd square the first term, double the product of the two terms. 2 times x times 5 is 10x. And then square the last term. Okay. Again, think about if you foiled this out and just wrote it as x plus 5 times x plus 5, x times x would be the first. That gets me the x squared. Outside would be x times positive 5, which is 5x. Inside would be positive 5 times x, which is another positive 5x. So positive 5x and positive 5x makes 10x. And then last term squared, the last would have been 5 times 5 is 25. Okay. The only thing that's different when it's a minus b is that our middle term is going to be negative, right? Why is that? Because it's negative 2ab, right? But other than that, it's gonna be the same. You might be saying, well, why is the last term positive? Well, remember, anytime I multiply a number by itself, so even if it's negative b times negative b, that gets me positive b squared, okay? And here's an example of how that one works there. All right. That's it. Basically, if you see that you have a binomial squared, you don't need to FOIL. Just go, oh, square the first term, double the products of the two terms. So here we would have first term squared is x squared. Double the product of the two terms. What's the product of the two terms? It's x times positive 7. That's positive 7x. Doubled means multiplied by 2. So we have 14x. And then square the last term, 49. Simple as that. Okay, try the rest of these. Okay. Okay, hopefully for this one, you got 49x squared minus 42x plus 9. How do we get that? First term squared, 7x times 7x, 49x squared. What's the product of the two terms? Negative 21x doubled, negative 42x, square the last term, negative 3 times negative 3, positive 9. Okay, and hopefully for these, you got those. Okay, same thing. If you recognize that it's a binomial squared, either something in the form of a plus b or a minus b, same pattern. Don't have to FOIL. In other words, you're doing these boom, 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 boom again, so you can get to your Snapchats faster. Okay. If you want to take a break, this is a good place to take a short break. I know we haven't done too much at this point, but this is kind of like the second half of the lesson. Okay, so now notice we are not multiplying the same binomial times itself. We're multiplying again what we call conjugate binomials. Conjugate binomials again, first term's the same. Notice the a and the a, right? X and x. But the last terms are opposites of each other. Positive b, negative b. Positive 3, negative 3. And what I want you to think about is if we did this as algebra tiles, a times a squared, positive b times a, positive ab, positive b, positive a times negative b, negative ab, positive b times negative b squared. What cancels? Where are like terms? Right here in green, they cancel out, okay? That will always happen. If you're multiplying the outsides and insides, if you're foiling, will always cancel if you have conjugate binomials. So why bother foiling? If you know it's going to end up being just the first term squared, a times a squared, and then minus the last term squared, okay? We call those difference of 2 squared. So here it's b squared, so minus b squared. Here it's 3, so it's negative 9. It's 3 times negative 3, okay? Simple as that. So fast. Okay, so try these. Let's do the first one together. Oh, conjugate binomials, x plus 5, x minus 5. I don't need to FOIL. I just know it's the first term squared minus difference, the second term squared. That's it. Okay. Could you FOIL them out? Yeah, you could. And you'd be wasting time. And we're not going to waste time. We want to be efficient. Okay, so continue trying these. All right, I'm back. And hopefully you got that and that. Simple, as simple as that. This is just a great way of just making it easier for you. Okay. All right. Now, this is kind of fun. This is like good mental math stuff, but so we're going to use special product patterns to find the product 26 times 34. You're going to be able to astound your folks and family at home. Oh my gosh. Okay. Notice that 26 is 4 less than 30, while 34 is 4 more than 30. So couldn't we write 26 is 30 minus 4 and 34 is 30 plus 4? Sure, of course we could. Didn't we just make conjugate binomials? First term's the same, second term's opposite. And then apply what we learned, which means we're going to just do first term squared minus the second term squared, difference of 2 squares, right? So 30 squared, easy to do, right? 30 times 30 we know is 900. 3 times 3, add 2 zeros on. And we know 4 squared is 16. And you can do that in your head. Okay, so how would you rewrite 21 times 21? Using this kind of stuff. Good. 20 plus 1 times 20 plus 1. Is that a pattern? Is it the same as this pattern? No, but it's still a pattern. What do we have? We have the same binomial squared, right? So we could FOIL it out, or we know it's just going to be 20 squared plus double the product, right? The product of 20 times 1 is 20. Double it means multiply it by 2, and then square the last term. And you can do all of this in your head. So 20 squared, we know, is 400. 2 times 20 is 40. Easy stuff to do, okay? All right. So let's move on. Okay, we're going to look. Oh, this is cool. This is probably a connection for you with science. Okay, a combination of 2 genes determines the color of the dark patches of a border collie's coat. An offspring inherits 1 patch color gene from each parent. Each parent has 2 color genes, and the offspring has an equal chance of inheriting either one. The gene capital B is for black patches, and the gene lowercase r is for red patches. Any gene combination with a capital B results in black patches. So that's kind of what we would call the dominant gene. Suppose each parent has the same gene combination, capital B, R. The Punnett square shows the possible gene combinations of the offspring and the resulting patch color. So we can see that. Here's one parent, capital B, R. Here's the other parent, capital B, R. Okay. So what are the possibilities? Well, here's your Punnett square. B and B makes BB. RB makes BR. Sounds like RB's roast beef. RR makes RR, and BR makes BR. So what's the possible, what percent of the possible combinations result in black patches? What would you say? 5%, 1, 2, 3 out of 4, right? Show how you could use a polynomial to model the possible gene combinations. Well, wouldn't this just be B plus R squared, which comes out to B squared plus 2RB or 2BR, whatever, plus R squared. Okay. All right, this one, very same, except here it's dogs that have 1 black gene, capital B, and 1 white gene, capital W. The Punnett square shows the possible gene combination of an offspring and the result. Okay, what percent of the possible gene could result in black? Notice we got black. What percent? 25, yeah. So we don't have a dominant gene, I guess, here necessarily, okay? And again, how would we model this? Well, isn't this the same as B plus W, quantity squared? Square it quickly, and there you have it. 1 where it's black, 2 where it's gray, 1 where it's white. All right, cool. Well, that is it for 7.3, quick one. Hope you enjoyed the lesson, and I will see you very soon.